Okay, now let's move on to study the most important section of this chapter, bond valuation. Uh, as the title says, the main objective of this section is to study pricing bonds. And in the middle of a term, how are you going to calculate the price for the remaining terms, and how are you going to apply the amortization method we already studied in the previous chapter to apply here for the bond problems. Nevertheless, in this video, we will mainly study the terminology and how we're going to price at the very beginning. Meaning, if I'm going to issue a 10-year bond, we are pricing at time zero. At time zero, there are 10 years left to go. So that's likely the easiest case. Okay, we already know for bonds, we can roughly categorize them into coupon bonds and zero coupon bonds. We don't really need to distinguish them in this section because later on there will be a coupon rate. You can always set the coupon rate to be zero. Then we get the case of zero coupon bonds. So there's no need to really distinguish them. We just do it in a uniform way. In what follows, our discussions are based on coupon bonds, right? So again, as long as you set the coupon to zero, you go back to zero coupon bonds. For coupon bonds, you can separate the payments into all other payments and the last one, okay? And that's because there is a significant difference. The difference comes from we have regular interest payments. Those we call them coupons. So for interest payments, we call them coupons. They are often paid semi-annually. Okay, of course, it's possible that they are paid annually or even more frequently than semi-annually. The second type is what we call the redemption payment. This is the amount the bond issuer pays at the final time, which we call the maturity time, to pay off the bond. Okay, it has the same sense as the principal of a loan, right? So that is the redemption payment. It's regulated or is written in the contract when the bond is issued. Okay, so with those two types, the last payment of a bond consists of both of them, right? It has the regular payments part, which is pretty much the coupon, and the other part is the redemption payment. So the last payment is going to be different from the rest. The rest of payments only include coupons. So let's say there are 20 payments, then from the 1st to the 19th payments, they are the same. They are the coupon payments. But for the 20th payment, it will have two parts. Part 1 is the coupons. Part 2 is the redemption payment. Now let's move to introduce several important characteristics, or rather features of a bond. First, we need a par value. So what is a par value? So for a specific bond, its par value, often also called nominal value or face value. Those three names, they are the same. So par value, nominal value, and face value. Well, it's not so often we use face amount. But sometimes, I might also call it face value. Okay, they all mean the same thing. Technically speaking, as suggested by nominal, it has no actual meaning. We need par value to calculate coupons and redemption payments because they are often quoted in percentage. So let's say we have a coupon bond with 5% coupon rate paid annually. So 5% is the annual coupon rate. But that's not enough, right? How are you going to calculate the exact amount to be received for each coupon? We need an amount, then we use amount times coupon rate to calculate the amount of interest, right? So that's when this value kicks in. We need a par value, we need a nominal value in order to calculate coupons, right? So let's say par value is $100, then I know each year the coupon payment is $5. I get it from 100 times the coupon rate, 5%, okay, that's $5, right? If the par value is $1,000, then the coupon payment would be $50. So that's when you use them, okay? And our default assumption is that the par value is equal to the redemption payment. So that means it's redeemed at par. Sometimes we also call it redeemed at 100% because it's equal, right? 100% is 1. It's the default assumption, but that does not mean we always assume that. Okay, bonds may be redeemed above or below the par value. So this percentage can be 120. So par value is $100, but the redemption payment is $120. Okay, and it can be below 100%. Let's say 90%. Then in my case, the redemption payment would be $90, right? But in most cases, we assume the redemption value is equal to the par value. So that is what we usually write: redeemed at par or redeemed at 100%. The second feature is obviously the coupon rate. That's important, right? It par value and coupon rates together calculates the amount of coupons, right? So the payment. This is often quoted as a nominal interest rate, convertible semi-annually. The reason is because coupons are often paid semi-annually. That's why we quote it as a nominal interest rate, convertible semi-annually. So this interest rate divided by 2 will give you the semi-annual coupon rate. So for instance, assume the par value is $100 and the coupon rate is 6% convertible semi-annually. Then each coupon is $100 times half of 6%, right? 6% is nominal rate, convertible semi-annually. So for each 6 months, the interest rate would be 3%. So 3% times 100, so it's 3, not 30. So we'll give you $3 every 6 months. So if you buy such a bond, you will receive $3 every 6 months. And of course, by the end of at the maturity date, you will receive $3 plus the redemption payment, right? And then it depends on whether it's redeemed at par or not, right? Assuming it is redeemed at the par, then your last payment would be $103, okay? The last feature is term. So how long is the bond, right? So the length of the time, right? The final time, we usually call it maturity. So let's say I issue a bond with 10 years term. So 10 years would be the term, right? And depending on the frequency, right? If it's paid annually, then there will be 10 payments. If it's paid semi-annually, there will be 20 payments, right? So it's very easy to figure out. Often we want to use YTM, the so-called yield to maturity, to somehow, it's a performance measure, right? Yield to maturity. Yield, in a sense, is just the interest rate. So how it is defined? This yield to maturity is the internal rate of return on the bond. In other words, this is well, in most case we call it. Well, let me put it the annual. Let me remove annual, because sometimes it's it may not be the annual rate. It may be semi-annual. So let's call it the interest rate such that it is priced in this way, right? On the right-hand side is the cash flows for the bond holder, right? So this is what he will receive if he buys this bond, right? The present value, okay? He will receive some coupons, and at the maturity, he will receive the redemption payment. So we calculate the present values for them, and on the right-hand side, it would be the present value of this bond, right? Okay, left-hand side should be the price. So this yield is the interest rate such that when you discount on the right-hand side, you get equality. So that is the yield to maturity, right? That is easy to understand. We often just call it the yield rate, right? That's quite often. We don't want to use yield to maturity. We just use yield to denote this. This is not always a good choice because there can be other yields. And here I give you another example. Okay, current yield. The current yield is the annual coupon amount divided by the bond price. So this is obviously different from the yield to maturity, but well, this is not often quoted, right? So it's not that important. So if you see yield, you can assume it is the yield to maturity. The price. When we talk about price, obviously it relies on the par value, right? Because par value determines the coupons and the redemption payment, right? So using this, if you look at this formula, in order to calculate the bond price, you need to know the right-hand side, right? Right-hand side has coupons and the redemption payments. Both depend on the par value, right? So when you calculate the bond price, it's quoted for a certain face amount. In most cases, it's either $100 or $1,000. That's because those are nice numbers, help us better understand everything. Let's solve a specific example, and then you will get a better idea of coupon payments and redemption value. So here we have a 10-year bond, just issued. So we are at time 0. There are 10 years to go. It provides semi-annual coupons of 6% in areas. This means all the payments are at the end of each period, meaning it's similar to annuity immediate. All the payments are made at the end of each period. Here would be at the end of every 6 months. It's redeemed at par, so the redemption value is the same as par. What price is paid? Okay, per $100 nominal value if the bond yields an annual effective rate of interest of 8%. This is IRR, right? Internal rate of return. This is your yield to maturity, YTM as well. First, let's draw a graph. This always helps. So it's a 10-year bond. So I draw it to 10 years. It's semi-annual. So here is half. Is 1.5 all the way to 9.5, right? This is when I get my coupons. How do I calculate a coupon? I have $100 nominal value. So $100 times by my coupon rate. My coupon rate is 6%, but it's a nominal interest rate convertible semi-annually. So for each 6 months, I need to divide it by 2. So the size of each coupon is $3. Goes on and on. Here I have $3, $3, $3. Those are the coupons. So meaning a fixed payment of $3 will be received every 6 months. Okay. Then at the end of this coupon, at the end of this bond, excuse me, this is the maturity, right? The holder will receive the redemption value. Since it is redeemed at par, it will be equal to the par value, which is $100. So this is the redemption payment. So this is the cash flows. So $3 are received every 6 months. In the end, the buyer will also receive $100. So how are you going to calculate the price? Price equals PV of coupons plus PV of redemption payments. Okay. So here we have annuity immediate, right? So we have 3 times annuity immediate. How many payments? I have 20. But here it's not I, it's rather J, which I will talk about. The PV of redemption value is $100. So here, let's also use J. So J is obviously the semi-annual interest rate. So here I need to discount by 20. That's because 10 years is 26 months. Right? So if you do the conversion. So here J is going to be 1 plus 8%. Take half power minus 1. Right? So you can get this. It's about 3.923%. So this is the effective semi-annual interest rate or semi-annual yield. Okay. This is my preference. The textbook also shows another way, right? You can take a look. I don't want to confuse you, so I only give you one method, right? So sometimes, giving you different methods might even confuse you. So knowing one at least will allow you to solve this question. You can do the standard calculation, calculate the present value of this A, and then do this. Actually, if you have the financial calculator, you can do it in one step. So what you do is you hit 20 for N, right? And then your interest rate, 3.923. So again, it's always in percentage. So there's no need to type percentage for your interest rate. Okay, and your payments is, well, it depends on whether you want to put negative or positive value. Let's do it for the same side. Let's put positive. So 3 would be the each payment, right? So that's PMT. By the way, I have Texas Instruments BA2. So the calculator I use is BA2 plus. Okay, yours might be different. Future value is $100. Put it for future value. And now what you do is you hit CPT, and then you hit present value. This will give you the result in one step. So for instance, let me give it a try. Let me remove everything. 20 is the number, 3.925 is the interest rate, 3 is PMT, 100 is future value. I compute my PV is a negative value, 87.370165, etc. So this is negative, meaning this is the price you're going to pay, right? Because I assume if you pay this price, you will receive $3 for the next 20 semi-annual terms, and you will also receive $100 at the end of 20. Okay, 26 months, right? Then it's 10 years. So that saves you time to do the computation, right? So you can do it in one step. With that in mind, let's formally introduce everything. Okay, the notations, and we will go from there. P is obviously price. So that's the bond price, is P. F is the face value. F, is the first letter of face value, face amount or par value, nominal value, whatever you want to call it. Small r is the coupon rate. This is no longer the interest rate. This is the coupon rate, very important, per payment period. So in our previous example, it's going to be semi-annually because it's paid as semi-annually. So this is the coupon rate per payment period. So in this example, R is not 6%, R is actually 3% because you need to convert this semi-annually. G is the coupon rate per payment period in terms of redemption amount. If face amount and the redemption amount are equal, meaning they are redeemed at par, then R and G are equal, right? But sometimes they may be not, then this is G can be different from R. Often what you see is R. I is the yield to maturity. Again, it is per payment period. C is the redemption value or redemption amount. C is equal to F in the default setup, but it does not have to be that way, right? So if C equals F, that means it's redeemed at par or redeemed at 100%. K is the present value of the redemption. So meaning this will be C times the discount factor. G is what we call the base value. Okay, I have a quick note down here. Small n is the number of coupon payments. So here it's a 10-year bond, but it's paid semi-annually. So small n is 20. So small n is 20, not 10. Okay. Many of the above notations are defined on a per payment period basis. So be careful to do the conversion if it's given to you as a nominal interest rate or given to you something that does not match the payment period, then you need to convert it. So in particular, I mentioned that pay special attention to the yield to maturity I. Here, let's discuss a little more of this base amount. So F is the face amount, base amount. R is the coupon rate. So F times R will be the size of each coupon divided by the interest rate or the yield rate per payment period. This is the present value of a perpetuity immediate, right? So if you recall what we started in chapter 2, probably, right? So what is the present value of a perpetuity immediate? Is 1 over I, right? Assuming the payment is $1. So here it's not $1, it's actually the coupon payments, right? Divided by I. So you can think G as the present value of perpetuity immediate with coupons never stop, right? For a regular bond, it stops somewhere. In this example, the coupon payments will stop after 10 years, meaning after 20 payments, it will stop. But G is the value such that, or equivalently, this cash flows will continue forever. So $3 of coupons will paid every 6 months forever. The base value would be the present value for such a cash stream. Here, after we introduce all the notations, we can easily calculate the bond price. But now, the bond price does not need to be at the beginning. So it's possible that someone is willing to buy a bond, let's say after a few terms, after a few payments. So in the previous example, here when we talk about the price, it's the price at the beginning, right? At the issue. This is a 10-year bond. But it's possible that, let's say 2 years later, the holder of this bond wants to sell, right? Then how are you going to recalculate the price 2 years after into the lifetime of this bond, right? Meaning there are 8 years left, 16 payments left, right? How are you going to calculate the bond price at that time? So, well, it's not complicated, right? We just need to apply the basic rule, discounting, right? So the price now, I assume I have n remaining. So here n is a little different from the n down here. So since there are n left, and I know the coupon is f times r, so this is the size of coupon, I need to times by the present value of the remaining ones, right? Again, here I will match the payment period plus the face value times the discount. Okay, sometimes we call the second one K, because this is the present value of the redemption value. There is an alternative formula. Okay, so let me also put a bracket. If you feel you can understand, that's better. If not, stick to my first formula. Okay, this is the annual payment. FR is semi-annual payment. When I double, it's going to be the annual payment. Because it's paid twice a year, so it's A upper 2, but it's not N, it's half N, because 1 year has 2 payments. But here it's not the interest rate, you need to be convert, right? Because here I is the semi-annual interest rate, you need to convert it to annual. So that's why I don't put it down there. And for the same reason, let's put K. K is the same. Okay, the second formula, I put it down here, but I don't use it in this video. Okay, the textbook also mentions 2 types of risk, but both are very easy to understand, right? When you buy a bond, the coupon rate is fixed, let's say 6%. But sometimes, well, oftentimes, the market interest rate is fluctuating, right? So if you bought a bond with, let's say, 5% coupon rate 2 years ago, and the bond lasts for 10 years. So for the next 10 years, you will enjoy 5% coupon rate. So let's say paid annually, so 5% every year. But if the current interest rate goes up to 10%, you are actually losing, right? You bought something that promised you a lot less, because if you didn't buy that bond, you could use your money to purchase something right in the market to earn 10%, right? So there is a risk to you. But of course, the market interest rate could go down, right? So let's say 2 years ago, you bought a bond with 5% coupon rate. Maybe right now, the market interest rate is just 1%, right? Then you made you made a wonderful deal back 2 years ago, right? So that's the interest rate risk. There's also default risk, because the bond is often issued by some companies. If the company goes bankrupt, of course you may not be able to receive all the coupons, right? You may not even receive the full redemption value back. So there is a default risk. Your investment may lose value when the company goes bankrupt. Here we have actually a very easy example. I think this is too easy to do, because the price we know, and we know the redemption value is 1,000, right? How are I going to discount back, right? So here we want the annual, so it's simply 1 plus I to negative 20. So this is too easy. Eh? So you can easily solve this to get the answer. It's about 3.14%. Next, well, let's solve next question. It's more meaningful. This has a bond pays coupons at the annual rate of 10%. Again, it's semi-annual. So 2 coupons a year. Nominal interest rate is 10%. So the actual interest rate would be 5% for each coupon. I is 4%, but that is annual. The price, we know. The bond is redeemed after 7 years. Calculate the redemption payments. Okay, so let's review what we have done here. Okay, we know P. price is 1404.06, and we know the face value is 1,000, and we know the coupon rate is 5%. And well, we don't know the effective semi-annual, so I'm going to convert it into semi-annual. So this is what I do, right? In order to get it into semi-annual interest rate, if you do the computation, it will be about a little less 2%. So now let's apply our formula. The price would be the coupon for each term times A, okay, 7 years. So I have 14 coupon payments. At I have already done the conversion. So it's I. Please do not plug in 4%. 4% is annual effective. It's not semi-annual. So I have to convert it. And then I need to do the present value for the redemption. Well, this is, I don't know. So I actually need to calculate. So let's call it C. And then I will need to 1 plus I to negative 20, not 20, negative 14. Right? By the way, this is also the same as 1 plus 4% to negative 7, right? That will save you time. Okay, so well, then we just need to do the calculation because we know everything except this C, right? So we can plug in the values, do the computation. We will get C is $1,050. So the redemption value is actually bigger than the face value, right? So does not need to be redeemed 100%, can be redeemed higher than the face value, right? The face amount. The next question discusses something different, right? So we can calculate with everything given except the one we can calculate, right? So here we know everything. We don't know the redemption value. We can calculate. In the next question, we know everything except n. We can calculate. So let's take a look. So here is the n year. So here is the year, not the number of payments. So be careful of that. Coupon is 5% semi-annual. So let me write it down. So it's 5% divided by 2. Annual effective interest rate is 8%. Again, I will need to convert it into semi-annual interest rate. So if you do the conversion, I leave that to you to calculate. The price paid, so I know P is $86, and I know the face amount is $100. The redemption value is redeemed at 110% times F, so it will be $110. I need to locate N. So now let's write down the equation. Okay, so F times R, A. Okay, so let me put a different color because they put N as a different meaning, right? N is the number of years. In our standard notation, N is the number of payments. So here it would be 2N. So that's we should bring textbook, right, by introducing different notation. Here is I plus C times the discount. Well, you can either use I or use the original 8%. It's up to you. If you use I, it would be negative 2N, right? Well, you can also write it in 8% if you want. So let me write it again using 8%. So then it's negative N, right? Calculating this is a little challenging because it's non-linear. So what you can do is you can test, right? So what you can do is let's try n equals 5, okay? And then we do the right-hand side. Okay, Right hand side, it's more than that. So you should try another one. Right hand side is 85.16. So it's something in between, right? What you can next step is to do the linear integration. But for this one, you can actually get the you can calculate Vn by writing down. So let me write down the equation. So F times R will be 2.5 divided by I. I you already know, right? So you can assume, or you can let, I don't know what you want. Let's use V U to denote this guy, right? Then what I have, 1 minus U divided by I plus C times U, right? So you can calculate U is about 0.48135. From there, you can calculate N. N is 9.5, okay? So calculating N is always difficult, but you can also use trial and error if you want. In the end of this video, we introduce two concepts. This is really easy concept. A bond is called a premium bond if the price is bigger than the redemption value. So, and the premium is simply the price minus the redemption value because P is bigger than C. So this is positive. If the opposite is true, if the price is smaller than the redemption, then this bond is called a discount bond. Then we can also define the discount as the redemption value minus the price. Okay, when will we get a premium bond? Is when the rate G is greater than the rate I. So what is rate G? Rate G is the coupon rate in terms of redemption amount, right? So if you are paid more than the discount or than the market interest, of course you should be paying more, right? If what you receive is less than the market interest rate, you will pay less than the redemption value, right? It makes perfect sense down there. I will end here for this video. In the next, we are going to study the amortization of everything. In principle, it's that task is very similar, if not identical, to what we studied in chapter 5.